Hi folks, welcome to the cam portion of the Wednesday Widget Fusion Friday Star Wars Christmas Bonanza here. New setup. It'll be a fixed size box, 8x6 by 1.22. Looks good to me. Okay, now the goal here is KISS, keep it simple. 3D adaptive. That screams sheer hog. Never have liked the filters, at least so far. Okay, here we go. I really should be using a template. I need to clean up my templates and then get them back to being used. We'll share our templates for sure once we get them fixed. Okay, so actually let me fix this real quick. So the bottom height, this is important. Selection of this, because the area below that is being held by the Talon grip. We'll share this file as well on our Patreon page if you guys want to make your own or follow along, or we'll just have fun. So obviously we want 3D adaptive to take into account the various 3D features, but I want it to come down a little bit lower here. See how it's not getting any of this tapered? And we're just roughing it, but I still want it to do that. And the reason it's not is under geometry, it's got tool center on boundary. So it's locking the tool path to this boundary sort of right here, the center of the tool, that's further you can go. I don't really care here, so we can just say tool center, tool outside of boundary. See if that makes it any better. Looks much better. Awesome. We'll hit Control D. We'll duplicate that exact same op, but let's come in with a 1/4 inch square shouldered end mill for now to do the same thing, but then we'll check rest machining from previous operations, and that's going to go through and look at what's left to be machined. So in other words, what couldn't the shear hog get into? So I'm sure it'll be some areas in here, hopefully some areas inside of here, maybe some corners, that kind of stuff. These rest machining ops and the adaptive ops both take a lot more time to compute for obvious reasons. So if I get something locked down in this instance, I may want to right click on it and choose protect. That way if I hop in or if I do something, I don't accidentally force it to regen the whole time. So that's exactly what I was hoping to see. I'm going to edit my step over here. Optimal load. Oh, that's because I adjusted for the shear hog. So I'm going to only go say 0.25 times 0.25, so that should be 0.0625. Step down can be 0.3. Fine step down 0.1 for now. And we'll say 0.05. Looks good. Click OK. Cool. So let's do a sim and just see what we're at, where we're at. Awesome. Actually, it's not really that bad. So I don't know. Did it get? Yeah, I got some of that. Didn't get a ton of this side stuff. I think I'm going to allow the toolpath some additional offset because it's not going all the way down as far as it can. So under additional boundary, I'm just going to say 1 inch. That's way too much, but it's a smart strategy. So it's not going to cut air, and there's nothing else that it's going to collide into on the outside the perimeter of the model. So this actually should do a better job. See that? See how it's now actually going all the way down as we would hope and expect? Great. So again, if you guys didn't watch the CAD video, this is my fun treat to myself. You know, I love machining, but when it becomes your job, it's different, and this is my fun part. I have no expectations here other than to enjoy the process. Hope that you guys learned something in the CAD video, and we'll go set this up on the Tormach, and we'll let her rip, and hey, you know, it'll probably be an hour or two toolpath, but you know, who cares? We're just having fun. Boom, boom, boom. Okay, so we got the rough shape out. A lot of these pockets are out. So here's the question. Do I want to... I guess I'm going to come back with the horizontal and clean this up because we're still leaving some axial stock. With the shear hog, we need to. With the 1/4 inch tool, I wouldn't always do that. But horizontal will be good here. It'll add a little bit of time, but that's okay. So let's say 3D, horizontal. And you know what we might do? I might actually switch over to, I've got this tool that I don't use very often, tool 11. It's a roughing end mill. Actually does a great job with floor finishes. It's from Meritool, sort of ironically. I don't think of them as always the cutting tool source. And what we'll do is we'll do stock to leave. It's a corncob end mill, so I don't want it to touch any of the sidewalls. So we'll say give it 5 thou radial, but obviously no axial. And let's just click OK and see where it generates tool paths. The nice thing about the half-inch tool is obviously it's got a little bit of a bigger cut area, so it'll all else equal go a little bit quicker. Sweet. Did it get, yeah, got that. So let's go do some 2D contour cleanup stuff now. We'll do this with tool 31. So this guy, there. Can I fit around here? Yeah, I should be able to fit around here. Now on this stuff, one of the things I like to do, if I've already come in with a horizontal and cut the floor, in theory our floor should be good. So to try to avoid an additional tool mark on the floor here, because I'm only focused on cleaning up sidewalls, I'm going to stay stock to leave, nothing on the side or radius, but on the axial, I'm going to say 1/2 thou above it. Now, obviously you need to make sure your tools are very, very dialed in on their measurement heights for this to work. But if you do it correctly, then it should work and it should help prevent that floor finish from happening. Cool. So take a look at a simulation. Fast forward through everything. So one of the problems is we've got this little area right here. So let's fix that. We're going to do a 2D contour. Let's actually do it. Sorry. Let's do a 3D adaptive. You'll see why in a second. We'll pick a small tool. Say, I don't think 1/8 of an inch is going to work. Nope. I can already see that that's smaller than that. So let's create a new tool. Flat end mill. We'll say 1/16, 5100, and we'll call it 1/16. Now, if I just click, see the problem if I do a rest machining is that it's probably going to take forever to compute because it's got to analyze the whole model. So I think what we're going to do is create a quick sketch over here to constrain it to this area. Let me pause it here. I'll let this fast forward and see what happens. So it's been a minute. It's not even half done, and you can see it's farting around with toolpaths over here. Not what I want. So let's clear toolpath. Hop back into model. Rectangle. Doesn't matter what plane it's on. Say right here. And let's just drag a rectangle around this area. Stop sketch. Back into cam. And this adaptive, I want to say machining boundary selection of this. And don't need rest. Yeah, rest machine actually is smart now. Cool. So same stuff. And then look, boom. Focused in just on this area. Excellent. Make sure you turn that sketch off. One of the biggest mistake folks make in Fusion is leaving sketches on. It can cause major accidents on operator error stuff. So let's see here. I now want to handle the parallel or 3D toolpath of this. So let's switch to a ball end mill with a 3D toolpath. And I am going to try parallel. 1/3 inch ball end mill. Click OK. Machining boundary will be this. Step over. So I just leave it rough at like 0.1 for now. And let's make sure I like what it's going to do. I do. But again, we've got a couple things. We need to refine the step over, but we also see how it's stopping right there. This is another example of tool center on boundary. It's leaving the center line of the tool. So that's the lead in, but the blue is right at the edge of the part. I want it to come off a little so that it gets closer to. Now, in theory, not theory, in practice, we can't machine this all the way down perfectly unless we took a square shoulder tool and interpolated up from the bottom. Not the goal today. We're just having fun. So let's see here. Offsets, tool outside boundary. And again, it should not ever gouge our model, which is great. 0.05. We'll just narrow it down real quick to see what it looks like. Looks good. Let's do that Rob Lockwood trick of saying contact point boundary and see if that gets rid of some tool paths. I don't remember why wouldn't that there. Now I don't really want it to dive down in there, so what I will do to fix that, in fact what I'm going to do in general to make sure it doesn't ever gouge, like you can see it's leading in, it is in theory machining on the floor here. We're going to say the heights, bottom height will be this plus 0.001. So it's not going to dip below there. Great. Awesome. I like that. You know what? We're actually going to leave it like that, step over, and let's see if it gives it a kind of a cool texture. Let's grab a 2D adaptive with a 3/16 end mill. And do these little pockets. In this case, I know I say don't ever use adaptive for finishing strategy, but I'm fine with it here. Click OK. Ooh, you ever get that error with adaptive? It's almost certainly your helical ramp diameter. So reduce that to say 0.01 for now. Make sure it works. And you can see it does. Now I can get an idea that I can expand that out a little bit. 0.1 ought to work, actually. Yep, perfect. Reduce the... see how it's so much red? There's like all that extra red above the stock. So if you go to the same setting, it's got, because the ramp clearance height is 0.1 inches above, 0.01 is fine. In fact, we'll make that default for everything in Fusion, for me at least. Much better. Okay, so this is going to be a chamfer. That's a fillet. Let's do some work on that. 2D contour. We'll grab our tool 25, which is a 90-degree mill drill. Click on that line. Passes chamfer width, none needed because it's already modeled in CAD. It's 2.04 offset. Cool, looks good. Now, I am not great at some of these little 3D fillets, but I want to get better at it, so let's give it a try here. Well, 3D contour, somebody tell me in the comments below what's the right sort of toolpath I should be doing here. I definitely want to use a ball end mill, so 3/8 ball. I'm going to click here, and let's say contact point boundary, and maximum step down 0.05 thou. Click OK, see what we get. I needed to learn this stuff better. Ooh, wasn't what I expected. Okay, well let's control the height, use the height. Yeah, let's use heights. Well, I wonder if I can do avoid touch. So touch surfaces, click on this fillet. This would be awesome if this works right. Why is it wasting all that motion? Simulate, no stock. So that's, see here, click here. Okay, that's fine. I agree that I should cut there, but it shouldn't be cutting. Yeah, that's way past where it needed to be cutting. Well, it needs to cut there. Maybe it is. Yeah, maybe that's okay. God, that's too many step downs. All right, rather than fumble around with it, we're going to say maximum step down of 0.02 or 25 thou, and what else was I going to do? There you go, 3, but that's still absurdly slow. We can go way faster. So something like this, max RPMs, we can go 3 thou per rev, because we're cutting a very thin profile here. We'll make it that up on our to-do list of things I need to learn and share with you guys and get better at, because that's an important modeling skill. Well, the last thing I want to do, this is important, is under passes. If I do bottom up, that should machine it from the bottom up, which is great because I want to cut more with the side of the tool than the tip of the tool, if at all possible. Let's do a simulation and see, does it do that? Yeah, that's great. That, again, you've got much better surface footage and better strength in the tool and better gullet area for the chip to clear out and so forth down there. So it walks it all the way up like so. Great. Let's hit Control D, and let's do that now again for, probably can leave, I'm not even sure the selection matters. If I change that to that, see what happens. Cool. Just want to make sure, I don't want it to touch that floor, so I'm going to do height, bottom height would be selection of that plus 0.001 just to stay off of it. And I'll Control D, edit the new one. Excuse me. Touch surfaces now. I'm going to do this and this. We'll say heights, selection of this plus 1 thou. Click OK. Cool. I like it. So the last thing I'm going to do is put a little spot drill right in here, and we'll do some quick chamfering as well. 2D chamfer, and this is great because what we can do is deburr. So I don't want to do that whole thing. Let's hold down an Alt key, and that'll let me pick exactly what I want, which is these lines. And the 2D chamfer has this built-in 3D model collision. So as long as I stay, say, 5 thou off the model, that's great. We're just going to do an 0.5 chamfer, 0.6 offset. The more offset you do, the closer that tool can get to some of these inside corners, which is great. And we'll do a quick chamfer as well on these guys. So I want to make sure I don't crash. Switch over to wireframe view. Link in the video description on how you get this little plug-in down here, which is great. So it looks good. I don't think, oh, we would crash right here. Okay, so let's just reduce the offset. You know what, I want to leave the offset. We'll do it as a separate chamfer op. Duplicate it. Hold down Control and I can deselect them from this one. Okay, so look at the wireframe view here. We should be good. This is a little bit risky that you misread a blue toolpath line relative to the solid model, but I think we're okay. You know, if we look at this one here, that should be okay. And then when we look at this one, now the next one, we can see we're not going to crash there. Cool. All right, we're going to call that a wrap for the cam. Click here, though, if you want to go see us machine this thing. And if you just stuck around for the cam, Merry Christmas, folks. Take care. See you soon.